why the primary focus on reducing carbon dioxide emissions when there are other potent greenhouse gases like methane and nitrogen oxides? Are there efforts to reduce these other gases as well? Additionally, while promoting solar energy to meet our energy needs, how are we addressing the issue of e-waste generated from solar technology? Lastly, does the extraction of fossil fuels and minerals from the earth increase the risk of natural disasters such as earthquakes? Okay, multiple questions in one, but it's a good question. Yeah, we talk about reducing carbon dioxide emissions. There are other greenhouse gases, potent greenhouse gases like methane, which is again something that it's a hydrocarbon. Methane is what, CH4? If I know chemistry, I'm not that great at chemistry. Okay, I think it's CH4 methane. Okay, it has carbon, right? And then you have nitrogen oxides and all. But the major bulk of the greenhouse gases is carbon based compounds like carbon dioxide and methane and so on. Um, yeah, but we talk about carbon dioxide. How much carbon dioxide? Because the bulk is carbon dioxide. Are there efforts to reduce these other gases as well? I'm not sure. Right now, we are focusing on carbon dioxide because it is the biggest problem that we have. Right. Uh, so yeah, because carbon dioxide is the major greenhouse gas, and it is what is emitted. Let's say you burn coal, what comes out of it is carbon dioxide that mostly comes out. There are other gases also that come out, but the major gas that comes out as a byproduct of burning of coal is carbon dioxide. Once again, when you're combusting petrol, gasoline, kerosene, which is aviation fuel, or whatever other hydrocarbon petrochemical thing, the major byproduct of this is carbon dioxide. So it makes sense to talk in terms of carbon dioxide. Yeah, but of course, there are other greenhouse gases. When it comes to animal agriculture, there's the emission of methane, which is a big thing, and so on. But we focus on carbon dioxide because it is the major component of the greenhouse gases and the greenhouse effect. Now, talking about solar energy to meet our energy needs, of course, there's going to be e waste generated from solar technology. So let's say you have a solar panel, and a solar panel has a certain lifespan. Okay, it's going to have a certain time in which it is useful. It has a certain limited amount of utility. Let's say 5 years, 10 years, let's say hypothetically. Okay, after which it will no longer generate the amount of power that you need. So you're going to have to dispose of it and get a new one, right? So what happens to the thing that you dispose, the solar panel that you dispose? It's going to go into waste, and it's going to get hopefully recycled, or it just goes into a landfill, or what, I don't know, whatever happens. So that is the electronic waste, the e-waste that you're referring to over here. And obviously that's a problem. But the deal is this: all human activity produces waste. You just can't do a thing about it. Every biological activity produces waste, by the way. I'm sure you're aware of this. And biological activity on a large scale can transform the planet. What was the great oxygenation catastrophe? It was one of the first extinction events. I mean, before that, before this thing happened, the Earth was a very different place. The atmosphere was very different. There was no oxygen. It was for us a hellish place, a whole combination of highly noxious gases from our perspective. And then these microorganisms evolved, unicellular organisms that gave out a tremendous amount of oxygenation. And this oxygen was a poison for all other organisms, and it killed off most of them. There was one of the first extinction events, the great oxygenation catastrophe. And even today, oxygen in high concentrations and all that is poisonous for even us. So biological activity can produce waste that can transform the planet in a let's say deleterious fashion, right? So there is that. Then why do we have so much iron rust, iron ore? Where does iron ore come from? It comes from bacterial activity again, deep in the earth's antiquity. And when it comes to human activity, we need to extract resources from the environment. Even during the Stone Age, we used stones as resources. So we were, because our population was so low at the time, it did not have any real effect on the planet. But let's talk about a time about 5,000 years ago, when you have the Saraswati Sindhu phase of the Indian history, Indian civilization, in which the population of that region, northern and western India, was about 5 million. At that time, to sustain that population, obviously you would need to extract resources from the environment, the ecosystem, the ground. You would have to do mining, and also obviously that will have some effect Obviously, a 5 million human being population isn't great compared to what it is today. What, 7, 8 billion? And India's population is 1.4 billion. Now we're talking about genuine earth changing consequences. The point is, all human activity is going to create waste. It's going to affect the planet in some way or the other. And it's going to change the balance of the ecosystem, of the environment in some way or the other. So we do need transportation, we do need energy, we do need all that, and it all has to come from somewhere. Now, ideally, you want to have a clean source of energy. But- So even if you want to have a clean source of energy, like solar energy, you're gonna need to have these solar panels, and those solar panels eventually will generate waste. Or you could go for nuclear energy, but then it will produce nuclear waste, which is essentially just thermal stuff which you can dispose of safely. But yeah, that's a thing. So yeah, there's nothing you can do about it, no matter how much you optimize the technology and how much you try to reduce the impact on the planet. It's going to have an impact. And the last question is, does the extraction of fossil fuels and minerals from the earth increase the risk of natural disasters and such as earthquakes? Well, if you have a reservoir of petroleum that you completely empty, it's going to cause a void below the earth's surface, and that can obviously cause the displacement of soil and rock and whatever, and it can cause a minor localized earthquake. And more than that, it's actually damming up of water that causes natural disasters such as earthquakes. If you have a region that is of the planet that is hilly, lots of rivers, and you dam up like 50 of those rivers in a reasonably small area, then that can cause earthquakes and things like that, natural disasters, or it can cause flooding and so on. So yeah, it's not the extraction of fossil fuels and minerals from the earth, but it's damming up of water of rivers, etc., that has a higher chance of causing earthquakes and so on. But even the extraction of fossil fuels, petroleum, raw petroleum, if you completely empty out reservoirs, then it can cause the collapse of the reservoir because it leaves a void behind, and then it can perhaps cause an earthquake. So yeah, there we have it.